Hello, we will be starting the live in a couple of minutes. Just waiting for more people to join. Uh, can you please let me know if I'm audible? Uh, in the chat, you can just say yes or no. Good morning. Am I audible? Okay, thank you, Sakshi. Thank you. Hi, Raj. Good morning. Hi, Almas. Good morning. Okay, it is 11 a.m. Let's just wait for another 2 minutes and get started, and people will keep joining in. Meanwhile, anyone wants to s- share maybe like what do you think today's model could be? Like it's called Magic Pencil. What do you think we're gonna do? Any guesses? Okay, yeah. Sakshi is saying maybe to balance something. Yeah, maybe. Good guess. Good guess. I think when we think about magic, at least for me, the first two things that come to mind is either something gets disappeared or something gets balanced, something, some balancing activity. So yeah, let's see if we are going to disappear, make a pencil disappear, or are we going to balance a pencil? Could be either. Okay, I think we'll get started, right? So today's the activity that we're going to do today, or the model that we're going to build today, is very very close to my heart. I think the first time I saw it in action, like I couldn't believe my eyes that this is possible. And I remember the person who taught me this particular activity. I think mentioned this thing called uh, magic. Yeah, magic happens, science is magic, but what happens after you have done the magic, when you start deciphering, is when the true magic of science comes into play. And this thought keeps running in my head again and again, that science, like anything that we call magic, has something or the other to do with science or mathematics. So yeah, it's really fascinating, and I am sure you will have a lot of fun making it today. Let's get started, right? So you don't need a lot of things to make this. If you haven't gotten these already, you can quickly go around your room and grab. You just need three things, right? You need a pencil which is sharpened. It doesn't have to be fully sharp, like, but not a new pencil. It needs to have like the lead coming out. So one pencil you need. You need like a wire. I'm not sure, yeah, if you can see. Yeah, a wire that is bendable. That is one. And you need any like 100 to 150 grams, anything that weighs about 100 to 150 grams. Like it could be a stone, it could be like your Vicks bottle, it could be anything that you find that is that much. I have a fridge magnet because that was the most accessible thing, like a little burger. So yeah, these are the three things that you will need to make. It's a very very simple model. If time permits, we'll also probably like try to decipher what's happening. um, yeah, so I'll just give you all like a good 1 minute to just go around in your room, pick up these things, and let me know once you're ready and we can get started. Okay, yeah, let's get started. First, what we will be doing is we will take the pencil and the wire. Okay, you're going to wrap this wire around the pencil in such a way that it is held securely. Doesn't have to be too tight or too clean. It's okay, because it's also good if you can move the wire up and down, because then it helps in more experimentation once the model is completely ready, and you will see what I mean by that. So something like this should be enough. Yeah. Okay, once you have attached the pencil to one side of the wire, what you will do is you'll take your heavy object, whatever you've chosen, right? And again, wrap the wire around that as well. uh, I might not be able to show this fully on camera, but I hope I'm making sense. So wrap this completely around your heavy object. Okay. Right, this is how it should be. Make sure it doesn't fall off. Right, okay. Now, before we actually see this in action, I'd like to do one more thing with you all. um, let's say I try to balance this pencil on top of my finger. What do you think will happen to the pencil if I leave this hand, the hand at the top? Can you like quickly tell me in the chat, like what do you think will happen? Anyone? Okay, let's try, right? So the pencil fell, and how much ever, and there is still a groove in my finger, even still, yeah, it will fall, Almas, correct. It is not going to stay. How much ever concentration I put into it, it is not going to stay, right? Even with this end, actually, even with an end like this, which is fairly flatter on my finger, though it's very difficult to make it stand, right? um, so yeah, so it's not going to stand. What do you think the reason behind it falling is? Anyone? Why do you think it's falling? Why do you think the pencil falls? So the most common answer that I get for this question is that gravity. But honestly speaking, gravity will be acting at every point of this pencil, right? So ideally, gravity should, in fact, allow it to stay straight, because again, inertia. This is my the rest state of my pencil, but the pencil still chooses to fall, which means that there is the forces acting on this pencil in all directions are not balanced, which means this is not, um, it is experiencing in imbalanced force, like the force is not equal at all points, which is why it is falling off, right? While gravity it is a universal force, which means it's going to have the same effect on this side of the pencil and on this side of the pencil. But what is probably different in the pencil itself is the weight distribution, um, right? Which is why there, how much ever cylindrical and perfectly cylindrical this pencil looks, there are impurities, there are weight imbalances that are probably not visible to our human eye. Which is why, yeah, Almas, gravity, but gravity should be acting again on equally, because it is universal and we're looking at only one object. So I hope I'm making sense. Please let me know if I'm not. So I'm just going to put this pencil back, secure it, right? Okay. Now, so this is what my complete apparatus looks like. Okay, I have a pencil, I have a wire, bendable wire attached to it, and I have some weight attached to the other end of the wire. Now let's try to put the pencil back like this and see what happens. Before I do this, anyone who wants to quickly guess what might happen? Will the pencil fall? Will, I don't know, will it disappear? What do you think might happen? If I leave this hand, what will happen to the pencil? Let's see what will happen, right? I'm going to leave it in 3, 2, 1. It fell. Let's try again. 3, 2, 1. The pencil is standing on its own. I am not I don't know if I can show you exactly the, yeah, I think this should give you an idea. So the pencil is balancing on my finger without without any help. My other hand is here. There is nothing down. Table is very much lower. So this is what is happening. I can also balance it on my phone for that matter, and it is still going to stay. Can someone take a guess as to what might be happening? Why is this pencil, when I used it, I did the same thing when the pencil was not attached to this particular apparatus, but the pencil fell, right? But this time it is not falling, and I'm also holding it in the same way. There's nothing, there's no change in the way. I didn't go and put some glue and all of that, right? What do you think is probably happening in this case? And I can move it. If I want the pencil to be maybe standing a little more straight, I can do that as well. So I can move, make the pencil move, can do many things. I can, let's say, push this up and see what will happen. So fall, so I'll probably change the direction of the wire itself and then see, okay, it's still going to fall. Maybe that height might not really work. So I'll move it down, and again, we're back to the pencil magically balancing. Yes, Almas, it is a wow moment. Yes, but like I said, the person I learned science from told me that magic of science is not just in the experiment, but it's also in deciphering what is happening and what is the science behind it. So yes, anybody who wants to take a guess at what might be happening, why is this pencil staying, why is it not falling, even anything, even a single word answer, what is the reason behind it not falling? This is almost horizontal to the ground, if you can see, and I'm really not holding it. Yeah. um I will, like, I will share a little bit about what is happening here, right? So any object that, what will happen if I leave this, it's going to fall, right? Why? Because the earth pulls it towards itself, and the other name for it is earth's gravitational pull, right? Earth's gravitational pull is pulling this object, and it pulls every object. It pulls my phone, it pulls everything. Unless and until we prove that earth does not pull something towards itself, we are going to believe that earth pulls everything towards itself, right? Earth gravitational pull. So naturally, when this pencil is here, pencil is going to be pulled by the earth. So the pencil wants to fall, because, like we saw, pencil wants to fall always. Even in this case, the pencil wants to fall. It's not that the pencil does not want to fall, right? It is. It does want to fall. What about this? The heavy weight also wants to fall, because we can check this as well. Because if I drop this, if I leave it, it's going to fall. So again, this earth also pulls this, and earth also pulls this. Now let's see the direction in which the earth is pulling. Okay. So my pencil, which was, oops. Okay. Um, give me a second. Difference in weight of both the objects, maybe. Yeah, that does play a role, of course. Again, by weight, we also mean, because weight is something that is calculated um, relative to Earth, right? Mass is different from weight. Mass does not take gravity into account, but weight does take gravity into account. So yes, I will. Yes, Almas, you're right. So it does have to do with the weight, more so with the gravitational pull of Earth. Yes. So when I leave the pencil, okay, 1 second. Yes. Okay. So the pencil when oh no, sorry. Okay. Yeah. When the pencil was straight, so it wants to fall this way. So because the Earth is pulling it this way, right? Earth is pulling it this way, which is why it's fallen this way. What about this object? Which direction will the Earth pull this object in? This direction, right? Earth will pull it in this direction. This direction. So this, when the Earth pulls the pencil in this direction, naturally what happens? This is going up. Do you see the weight going up? But the weight can't go up because the Earth also was pulling it this way. So the pencil is moving the weight this way, but the weight wants to come back down, and that gets balanced at some point. The force with which the pencil is pushing the weight up and the force with which the Earth is pulling the weight down gets balanced at a certain point. In this case, gets balanced at this point. So even if I say bend the pencil, it's going to come back to the same position. Do you see that? Because this is this has to just do with balancing of forces. We know that anything that is either moving or at rest will remain in that state unless and until there's some external force that acts on it and changes its state of rest or of motion, right? That's exactly what is happening here. And in our textbooks, this effect is called as torque. This or the turning effect, right? It's turning effect is a more friendlier term for us. But yeah, this is one way of teaching torque to your students, and you will see that different the length of this will make a difference. Length of this will make a difference. Everything will make a difference. So this is a good experiment that you can do with children in classrooms, especially in grade 8, grade 9, if I'm not wrong, where circular motion or torque comes into picture, force times distance, and all of that. Good starting activity. Um, yeah, Sakshi is saying forces on both objects trying to balance each other. Yeah, the force specifically here is the Earth's gravitational pull. That is, both want to go down, but because they are connected with this wire, they are influencing each other, which is what is allowing us to create that balance. You can try this with many other things. You can use a belt. You can use so many other things. I'm sure you'll find a lot of these experiments also on the internet. um, yeah, I think I hope you had fun. I hope you um, yeah, saw the magic in action and also try to decipher the magic. um, and yeah, any if you have any questions, we can maybe take that. If you have any thoughts that you want to share, we can take some time to do that and maybe say goodbye and have a good weekend. I'm also thinking if we can try it with something else. But unfortunately, I'm not finding anything else around me to try it with. Because my phone probably would be a little too heavy for this object. Um, Maybe this coaster should work. I'm not sure. It's too big. Okay. Sorry, I don't have any other heavy object at my disposal. Um, but yes, feel free to try with different objects, different shapes, different materials, size of objects, length of pencil, and all of that. I think you yourself will start discovering what are the variables that matter, like the variables that play a role in this balance. Like when will it balance like this, when will it balance like this, and all of that. So that also brings into account how scientific experiments really happen, right? They're not overnight. Scientists use different parameters, they use different variables, try different combinations, and then make conclusions. um, yeah, feel free to try this and like show it to your kids. I think every time I have done it with kids, they have just been so fascinated. And very interestingly, so whenever I have done this, I have not told them how it's working. I show them and I give them time to tell it them by themselves. So, and like kids especially, I have seen a fourth grader who has been able to so nicely explain how this is balancing, of course in their own simple words. Of course they have done it in Hindi. They have not used jargons like torque and all of that, but such great understanding and clarity that they have brought was like really interesting. So kids have the power to explain things on their own, because they do understand the world in a very nice way. So try this with your kids and let us know how it went. You can write to us, email us, you can reply, you can leave comments on the live that will get posted as a video after this. You can reach out to us on Instagram, Facebook, and yeah, tell us what your experience with this activity in your classroom was. Yes, Almas, it will really build curiosity. Yeah, yeah, it is. It's very fun. It's one of my favorite, like my favorite experiments, and it's most beautiful experiment, I think. And so simple, like I barely used anything. Yeah. Okay, folks, thank you so much for joining and for engaging. I hope you had fun and I hope you started your day with a lot of curiosity. And I'll see you guys sometime soon. Thank you, Raj. Thank you for making this possible. And have a nice day. Bye.